Hi everyone, Tina here, and today I'd like to talk about the discriminant. You'll usually come across this topic during year 1 of your A-level course. Let's start by looking at what the discriminant is. The discriminant is the algebra that's underneath the square root symbol in the quadratic formula. So b squared minus 4ac is what we call the discriminant. Now, when we're solving quadratic equations, if the bit under the square root is positive, that means you're going to get two different real solutions, because you're going to be adding or taking away something from minus b each time. If the bit under the square root is equal to 0, you're just going to get one repeated solution, because the square root of 0 is 0, so that's not going to give you two different answers. And then if the bit under the square root is less than 0, if you try to put that in your calculator, that's when you're going to get a math error. And that's because we can't square root a negative number. Therefore, there's going to be no real solutions. Let's explore these three scenarios a bit further. So scenario 1, the discriminant b squared minus 4ac is greater than 0, and that means you're going to have two real roots or solutions. So on a graph, if we were looking at just a quadratic graph, that might look something like this, because the graph will cross the x-axis at two distinct points or have two real roots. Sometimes we're not just looking at a quadratic on its own though, sometimes we're looking at this in the context of two things intersecting each other. So for example, we could have a quadratic curve here and a line, and they could intersect each other at two distinct points. If that's happening, then the combination of those two equations would lead to a discriminant greater than 0. Scenario 2, b squared minus 4ac is equal to 0. That's one repeated root or solution. So on a quadratic on its own, that would be one of the ones that just touches the x-axis once. In the context of a curve and a line, we may have a curve like this and then a line just touching it, in other words, a tangent to the curve, and they would only intersect once. Last scenario, b squared minus 4ac is less than 0. That means no real roots or solutions. So if a quadratic was on its own, it would not cross the x-axis. It would be floating somewhere like that. And in the context of having a curve and a line, the curve and the line would never intersect each other. I've got three examples for us to work through. Example 1, the equation x squared plus n plus 1x plus 3 minus 3n equals 0, where n is a constant, has two distinct real roots. Find the set of possible values for n. So here it's telling us that this quadratic has two distinct real roots. So straight away, we can think about the discriminant b squared minus 4ac, and that's got to be greater than 0 in this context. Because this is just a quadratic on its own, we can jump straight in and find the discriminant. A is going to be 1 in this case, b is n plus 1, and c is 3 minus 3n. If we pop those into the discriminant formula, we get this, and then we can expand and simplify. N squared plus 2n plus 1 minus 12 plus 12n greater than 0. Simplifying gives n squared plus 14n minus 11 is greater than 0. And now we just have a quadratic inequality to solve. So if you solve this being equal to 0 however you wish, you'll get n is equal to minus 7 plus 2 root 15, or n is minus 7 minus 2 root 15. Then because it's a quadratic inequality, we have to plot those on a sketch. So maybe something like this, where this one is the minus 7 minus 2 root 15, and this one is the minus 7 plus 2 root 15. Now, if we check the inequality, looks like we want to be greater than 0. So that's going to be this part and this part, the two arms of the quadratic. Therefore, final answer, n has got to be less than minus 7 minus 2 root 15, or n has got to be greater than minus 7 plus 2 root 15, and that's it. Example 2. The line y equals mx plus 2 is a tangent to the circle x minus 5 squared plus y plus 1 squared equals 15. Find the two possible values of m, giving your answers in exact form. So for this question, we have a circle and a tangent. So something like this, maybe. A tangent and a curve or a circle just meet at one point. So this is the scenario where the discriminant is going to be equal to 0. Before we can work with the discriminant, we need to combine the two equations to find the point of intersection. When you've got a linear equation and a quadratic equation, it's best to substitute the linear one into the quadratic one. So if we take this and substitute it into that one, so replace y, let's see what we get. So x minus 5 squared plus mx plus 2 plus 1 squared equals 15. So I've just replaced the y with mx plus 2. Then we can expand and simplify and go from there. The algebra can get a little bit messy with questions like this, so just be careful. Now bring everything over to one side so that it's equal to 0. And then we're going to collect the terms. So anything to do with x squared, let's collect that together. 1 plus m squared x squared. Anything to do with x, so we're going to have minus 10 plus 6m x. And then all the constants can merge together to give plus 19. This is the quadratic that we're going to do the discriminant on. So once again, we said for this scenario, b squared minus 4ac is going to be equal to 0. And this time around, we've got a is this, b is this, and c is this. So if we sub those in, we're going to get this. Expand and simplify. Multiply the 4 and the 19 together here first to get 76, and then expand that with the bracket. Tidying up, we get this, minus 40m squared minus 120m plus 24 is equal to 0. This you can solve using the quadratic formula, for example. And then we get the two answers for m. M equals minus 15 plus root 285 over 10, or m is minus 15 minus root 285 over 10. And that's it. Last example, the curve with equation y equals px squared minus 4px minus 5p, where p is a constant, does not intersect the line with equation y equals 2x minus 12. Part A, show that that inequality is true. So keywords here, curve does not intersect the line. So that means we've got a scenario where we may have a curve that looks like this and a line, but they'll never meet. Therefore, in terms of discriminant, we're in that third scenario, b squared minus 4ac has got to be less than 0. Again, in this question, because we're thinking about a curve and a line not intersecting, we have to find the combination of the two equations first before we can consider the discriminant. So let's substitute the linear equation into the curve equation. That will give us 2x minus 12 equals px squared minus 4px minus 5p. So just replacing the y with the 2x minus 12. I would then move everything over to the right-hand side and then collect all the terms together. So px squared's on its own in terms of the x squared terms. We've then got minus 4p minus 2 for x, and then minus 5p plus 12 on the end. We said b squared minus 4ac, or the discriminant, is going to be less than 0 in this case. So with a as p, b as this, and c as this, that would look like this. Expand and simplify. Tidying up is going to give this. Divide everything by 4 and you get what they're looking for. And then for part B, we're just going to try and solve that quadratic inequality that we just found. So solve the quadratic equal to 0 however you prefer, and you'll get p is equal to 4 plus root 7 over 9, or p equals 4 minus root 7 over 9. Then draw yourself a sketch, something like this. This can be the 4 minus, and this is the 4 plus. This time, the inequality is less than 0. That means we want to look underneath the x-axis, or the p-axis in this case, and the final answer will be p is between those two values. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already, and do share this with anyone else you think might find it helpful. Thanks, and see you next time.